Let's talk about the particle known as positron. What we know is that positron is an antiparticle of electron. It's an antiparticle of electron, and uh, it has all properties same as that of electron except charge, and its charge is positive. And it was Anderson in 1932 who discovered these particles, whom we call as positrons. And he discovered these positrons using a particle detector known as cloud chamber. And, and using this cloud chamber, a new particle in the course of his experiments on cosmic radiations that he was performing, and he could discover a particle known as positron. Now, this penetrating radiation produces high speed electrons. If we have cosmic radiation, what we have high speed electrons. And if I assume that this is a chamber kind of thing, and 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 this the radiation that's passed through this chamber, what it does is that the path of these electrons is observed. So if they are electrons, they happen to have a path like this, and 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 when some magnetic field was applied, say this is the magnetic field, and the magnetic field B was applied, uh, and on the application of this magnetic field to the cloud chamber, assuming it to be a cloud chamber, and observing the curvature. So now, on applying the magnetic field, there has some kind of curvatures are induced to these electrons, because when we apply the magnetic field on the charged particle, it certainly affects its trajectory. It does not experience any force on these charged particles, but it certainly disturbs its trajectory. And what was found was that majority of the particles that were produced were negatively charged, and but occasionally a particle was found whose curvature was opposite to that of electrons. And this could either be an electron moving in opposite direction, that could have been the possibility, or a particle moving in the same direction but having a positive charge. So what was done was that these particles, that the particles who had the opposite curvature, what was done with them was they were subjected to the lead plate, to the lead. They were subjected to the lead plate in the path of this particle, and the direction of motion of this particle was observed. And what was observed was, what was obtained, what was found was that the motion was same as that of electrons. Its motion was same as that of electrons. So, so hence it was concluded that it was a positively charged particle. Its dynamics is same as that of the electron, but at the same time, it experiences a force in opposite direction. Its trajectory passes in opposite direction, and this led them to uh, to claim that they have discovered a positively charged electron known as positron. Now, the measurements that were made on the curvature of this track that we have, and what was obtained was the decrease in energy on absorption in this lead plate. So once this radiation is allowed to pass this lead plate, there is decrease in energy, and the density of the droplets produced in some Wilson cloud chamber, they gave the similar results to those of an electron, and this positively charged particle therefore has the same mass and same charge as that of an electron, and is called as a positron. Now, the same charge, I mean to say that the nature of charge, the electron has a negative charge, and the same nature of charge is found on this particle, but the direction of that charge is opposite to the direction of an electron. So electron has a negative charge, and positron has a positive charge. Now, the existence of these positrons, it's also confirmed by the phenomenon of artificial radioactivity. So when we talked about artificial radioactivity, we talked about these positrons that come in addition of the disintegration of the nucleuses, where we have positive beta decay, and we do have the conformation of these positrons, the positively charged electrons. Now, there are a number of artificial radioactive elements which emit these positrons only, and some of them have fairly a long life. Okay, and it was Dirac, basically. Dirac postulated. Dirac postulated from his theory of atomic structure that he has, this theory of atomic structure, the existence of such particles before it was discovered by Anderson. So it was predicted by Dirac. So Anderson discovered it, but it was already predicted by Dirac. Now, according to him, such a particle is produced. According to Dirac, such particles are produced by the absorption of quantum of energy, by the absorption of quantum of some high energy radiation. And it has been shown that positrons can be produced on the bombardment of nucleus by neutrons. So if we have nucleuses and if we bombard them with neutrons, we have showers of positrons. We have showers of positrons. And Anderson showed that they are produced on they are produced on bombardment of nucleus by penetrating gamma rays also. So in such cases, electrons and positrons are produced in pairs, where we make use of nucleuses and we subject them to gamma ray particles. In such cases, we find them in pairs, like positron and electron. And the positron has no permanent existence in matter of ordinary density, and because it recombines with electron, and when it recombines with electron, what it does is it gives us the quantum of energy. It gives us quantum of energy, and this process of combining of an electron with the positron and giving birth to a gamma ray photon, this is called as electron positron. This is called as annihilation, and this annihilation is due to the pairing of electron and positron.